So we are starting the next half of the unit. We just took a test over circles and ellipses. So those are essentially done. We're going to take a test over hyperbolas and parabolas. For the hyperbolas, they're really close to being ellipses. So you should be really, really careful with what you're doing, but there's lots of similarities, so that's good too. So you're not learning brand new stuff. So here is a set of definitions. You don't have to know these by any way, shape, or form, but just so that you're aware. A hyperbola is a set of all points in the plane in which the difference of the two distances, of the distance from the two distinct fixed points called foci, is constant. So just like with your ellipses, you have a definition where we did that little applet. We're doing one with a hyperbola. And so instead of being added, those distances are being subtracted. So again, the foci aren't actually on the hyperbola, but they are there as part of the definition. The center is the midpoint of the line segment whose endpoints are the foci. Not hard to figure out. And the point on each branch of the hyperbola that's nearest the center is called the vertex. So if we have a horizontal hyperbola, and you've got one on your note sheet, if we draw this distance in, each of these endpoints would be a vertex. The center would be in the middle, of course. All right. So, and then the foci would be inside the parabola. All right. The asymptotes of a hyperbola are lines that the curve approaches as it recedes from the center. Without the asymptotes, we wouldn't know how wide or narrow our hyperbola needs to be. So you'll have two asymptotes. And as you move further along the branches, the distance between points on the hyperbola and the asymptote approaches zero. So your hyperbola will get closer and closer to these lines but never actually touch them. And then our hyperbola has two axes of symmetry. The line called the transverse axis. So when you're at this transverse axis. And so from the center to one vertex is going to be A. And we also have a conjugate axis. So the center and the opposite and so from the center to one of the points on the conjugate axis is just B. Okay? Similar things to ellipses, but not the exact same. Okay, you can fill out your note sheet with a table. The stuff that's highlighted is ready. One of the big differences is that in the equation there's a minus sign and a plus sign, and that's going to be important. Also, c squared is a squared plus c squared in this case, not a squared minus c squared. And since there's only one set of vertices, then you only have one vertices equation to memorize. Okay? So I'll get to write that down. And then we also have a vertical orientation. So this is why it doesn't matter. So with ellipses, you have x and y fractions which have them in any order. In this case, the order is the x fraction is important and y are missing then is the equations of the asymptote. And so here they are. I've written down for each point slope here. So with point slope form, you have y2 minus y1 equals n times x2 minus x1. And so you have the same thing as h and k, and then your slope is either b over a or a over b, depending on your orientation. You can't write that down as well. equations of the asymptotes and then graph the equation. The first one's easier because the center is 0, 0, so I'll do the more complicated one. First of all, we know a few things just by looking at the equation. First of all, we know it's vertical because the y is in front. I know that a is equal y is first. That is still k. It's still hk in the center, so be very careful. If I have that information, I should be able then to find the vertices without any problem. So if you have the vertices, you're going to do 2 and then 3 plus or minus a, which is 4. So I have 2, 7 and 2, negative 1 for my vertices. So now I'm missing a foci, so I need to find c. So c squared equals 16 plus 4, a squared plus b squared. So c squared equals 20. So c equals the square root of 20. So the foci will be at 2, 3 plus or minus the square root of 20. We don't have to graph those, so we can leave that in that format if you'd like. I have the center, I have the foci, I have the vertices, and so I need to find the equations of the asymptotes. So I do y minus k, which in this case was 3, equals plus or minus, this is vertical, so I put a divided by b, so 4 divided by 2, and x minus h was 2. So I have two equations, and I am going to simplify both of these. So first I have y minus 3 equals plus or minus 2, because 4 divided by 2 is 2. And then I'm going to separate this into two equations. So I have y minus 3 equals 2x minus 2. And I have y minus 3 equals negative 2x minus 2. So I do some algebra. I'm going to distribute. So 2x minus 4. And I'm going to add 3. So y equals 2x minus 1. For the other equation, negative 2x plus 4. I add 3 and I get negative 2x plus 7. Now that I have the center, the vertices, and the asymptotes, I can graph the hyperbola. So we'll start with the center. Center is at 2, 3. The vertices are at 2, 7, and 2, negative 1. And now I need to graph my two asymptotes. They're just linear equations. So I'm going to start at negative 1 on the y-axis. That's the y-intercept. And I'm going to go up 2 over 1. That's my first asymptote. And then the second one has an equation where my y-intercept is at 7, and my slope is negative 2. I'm going to go down 2 over 1. And so now I need to draw in my hyperbola. The curves should hug the asymptotes but never cross them. And there it is. That is Learning Target 9 to begin with, and we'll finish it tomorrow. So you can start the Learning Target 9 homework, but you can't finish it. We haven't talked about general form.